Mercury. You land on the surface of Mercury. No atmosphere. One side is 800 degrees Fahrenheit, the other is minus 290. Your blood starts to boil instantly. Your lungs rupture as the air inside them rapidly expands. But that's just the start. If you landed on the sun-facing side, you'd be incinerated faster than you could scream, turning into a charred husk in seconds. On the dark side, you'd flash freeze into a brittle, solid block of ice, a perfectly preserved, dead astronaut popsicle. The solar radiation would then hit you, cooking your remains from the inside out. Your corpse would be alternately boiled, frozen, and irradiated, all before your brain could fully register what was happening. A final, silent, cosmic double tap.
Venus. You're falling through Venus's atmosphere. It's 90 times thicker than Earth's, heavy with carbon dioxide and sulfuric acid. It's like being crushed under a mile of ocean water, but instead of water, it's superheated, corrosive air. Before you even hit the ground, the immense pressure would flatten your body into a pancake. Your bones would splinter, your organs would rupture, and any remaining moisture in your body boil away at 900 degrees Fahrenheit. The sulfuric acid rain would then begin to strip away your flesh, leaving nothing but a rapidly dissolving skeleton. Your last moments would be a terrifying combination of crushing, boiling, and corroding, all in a haze of toxic yellow. Not a quick death, but a comprehensive one.
You fall out of a submersible, sinking into the pitch-black abyss of the Mariana Trench. The surface quickly vanishes, replaced by an inky, crushing darkness. The pressure builds instantly. Your lungs, designed for sea-level air, collapse inward. Your eardrums rupture. Your body, mostly water, wouldn't be flattened completely, but the air pockets within you, your sinuses, your gut, whatever air is left in your lungs, would compress violently, turning your insides into a chaotic mess. You'd feel a sudden, agonizing squeeze, followed by a profound, cold silence. Your flesh might still cling to your bones, but internally you'd be a pulped, unrecognizable mass, sinking into the perpetual night, a nameless deep-sea monument to extreme pressure.
The Moon. You step onto the lunar surface without a suit. The first thing you'd feel is the instant vacuum ripping the air from your lungs. No sound, just a violent, silent exhalation. The oxygen in your blood would flash boil, turning your veins into a network of gas bubbles. Your skin would swell. Your eyes would bulge. If you landed in sunlight, the side of your body facing the sun would cook to over 200 degrees Fahrenheit, while the other side would freeze solid at minus 250 degrees Fahrenheit. All of this before you even had a chance to suffocate. You'd be a silently screaming, boiling, freezing, expanding, and rupturing husk, a twisted ice sculpture in the dust, until solar radiation quietly finishes the job, bleaching your remains for eternity.
Mars. You find yourself on the dusty red surface of Mars, without protection. The atmosphere, less than 1% of Earth's and mostly carbon dioxide, would immediately suck the air from your lungs. You'd gasp, but there'd be nothing to breathe. Your blood wouldn't boil as fast as on the Moon due to the slightly higher atmospheric pressure, but it would still start to effervesce, causing rapid expansion and cellular damage. The frigid temperatures, averaging minus 81 degrees Fahrenheit, would swiftly begin to freeze your exposed skin. You'd suffer from extreme hypothermia and suffocation simultaneously. You wouldn't last more than a minute or two, slowly freezing, swelling, and suffocating. Your frozen corpse would then be subjected to constant planet-wide dust storms, slowly sandblasting your remains until nothing but bone and a thin layer of red dust remained.
Jupiter. You plunge into the swirling clouds of Jupiter, a planet with no solid surface. As you fall deeper, the crushing pressure would rapidly intensify.
Your body, designed for Earth's gentle gravity, would be torn apart by the immense forces and then compressed into a dense, unrecognizable mass. The gaseous atmosphere, primarily hydrogen and helium, would superheat as you descend, reaching temperatures hot enough to melt solid rock. You wouldn't just be crushed, you'd be cooked, vaporized, and then compressed into liquid metallic hydrogen, becoming one with the planet's violent, stormy interior. Your death would be less of a physical experience and more of a total existential erasure, turning you into a subatomic component of a cosmic blender.
Saturn. You're drifting near Saturn's rings, then fall through its atmosphere. If you hit the rings, you'd be pulverized instantly by high-velocity chunks of ice and rock, turning into a fine cosmic dust. If you somehow missed them and plunged into the atmosphere, it would be a chilling repeat of Jupiter's horror, but colder. The atmosphere of hydrogen and helium, laced with ammonia ice, would flash freeze you almost instantly to temperatures around 285 degrees Fahrenheit. The crushing atmospheric pressure, increasing exponentially with depth, would then compress your frozen, brittle body into a tiny, dense, diamond-hard nugget. You wouldn't feel it for long. A quick freeze followed by an eternal crush. A silent, diamond-frozen tomb in a violent, gaseous sea.
Uranus. You're dropped into the icy depths of Uranus's atmosphere. This planet is a freezing, windy hell. The temperature rapidly plummets to minus 320 degrees Fahrenheit. You'd flash freeze faster than you could blink, your body becoming as brittle as glass. The atmosphere, a mix of hydrogen, helium, and methane, offers no breathable air. As you descend, the pressure would build with unimaginable force, squeezing your frozen remains. You'd be ripped apart by hurricane-force winds, far more powerful than any storm on Earth, then compressed and solidified into a methane-ammonia slush. Your existence would end in a silent, chilling pulverization, becoming just another ice crystal in the vast, turbulent, and utterly indifferent atmosphere of an ice giant.
Neptune. You tumble into Neptune's stormy atmosphere, the coldest and windiest planet in our solar system. The winds, stronger than any on Earth, would tear your body apart before you even began to freeze. Temperatures of minus 370 degrees Fahrenheit would instantly turn you into a frozen statue. The atmosphere, composed of hydrogen, helium, and methane, offers no oxygen, ensuring a quick, agonizing suffocation. As you descend, the pressure would crush your shattered, frozen remains into oblivion, deep within the planet's icy mantle. You wouldn't just freeze, you'd be flayed by supersonic winds, flash frozen, then compressed into a diamond-hard, unidentifiable shard of organic matter. A truly brutal, unfeeling end in the darkest, coldest corner of the solar system.
Pluto. You're adrift on Pluto, far at the edge of the solar system. The temperature is a staggering minus 387 degrees Fahrenheit. You'd instantly freeze solid, becoming a fragile statue of ice and organic matter. The thin, wispy nitrogen atmosphere, barely more than a vacuum, would steal any remaining air from your lungs, but the freezing would get you first. Your blood would not boil, it would simply freeze within your veins. Your body, now a brittle block of frozen tissue, would be completely motionless. There's no heat, no pressure, no life. You'd remain there, a perfectly preserved silent testament to the void, a tiny forgotten ice sculpture at the far reaches of human exploration, until some cosmic debris eventually, slowly, erodes your frozen remains.
The sun. You're falling toward the sun. There's no landing on a star. It's a colossal ball of superheated plasma. Before you even reached its outer atmosphere, the solar radiation would strip every cell from your body. Any organic matter would instantly vaporize, turning you into a stream of superheated gas.
As you plunge deeper, the intense heat and pressure would break down your molecular structure, then your atomic structure. You wouldn't experience pain or death. You'd simply cease to be, not as a recognizable form, but as a collection of atoms instantly integrated into the sun's furious hydrogen-fusing heart. Your last moments would be an instantaneous, blazing dissolution, becoming a part of the star's eternal inferno, an unnoticeable flicker in its boundless, destructive glory.